couple of things. We really should be talking about autisms, not autism, right? Because no two kids, people, whatever, are the same. And so that's why there isn't a protocol that works for everybody. There isn't just one cause, there are multiple causes, and I think that will be very apparent today. And there isn't just one treatment. And it's amazing why you can take one person and you give them X supplement and you get a phenomenal impact, and another one you can get nothing, or you can actually even get worse. I'm not going to get into the different sides of the immune system, Th1, Th2, and things like that, but if you have one child and part of their problem is their Th1 side of their immune system is ramped up, and you give them something that ramps it higher, you can actually get worse. Or if you took another child and the Th2 was up, if you know what I'm talking about, and you gave them that, you could see a phenomenal improvement. So you have to get a little deeper before you start deciding what to do. All right, there isn't a cure because it isn't one disease. It's the same thing with autism, which I treat a lot of in this office. And we do reverse the symptoms of autism and different Alzheimer's and different kinds of dementia. We do it every day. But there isn't a drug for Alzheimer's, and there isn't ever going to be one, because it isn't just one disease. All right? So what is it? It's the interaction between multiple different genes. It's a part, the environment's a part of it, right? Diet is a part of it. The immune system is a huge part of it. And we're not even talking about what goes on prenatal. Although all of those things apply to mom, right? So one thing I'm not going to talk about today is, prevention type of prenatal things, risk factors for moms and stuff like that. That's easy for you to find, okay? What we want to do is we want to look and find, come on in. Come on in. I did use deodorant, so you're welcome to sit closer if you'd like. I only do it when people show up. No, I'm just kidding. So what we want to do is we want to look for the root causes that we can actually have an impact on, and we want to be very, very precise about what we do. Okay? The time for guessing is over. You want to be very, very precise about what you do. So what we're going to talk about, I'm going to talk about what I call the 3 priorities. The first priority is autoimmunity. A lot of people don't even think about that. But we're going to spend some time on that. We're going to talk about inflammation. And we're going to look at some genetic risk factors that can give a person, a child, a problem resolving inflammatory byproducts. Their ability to methylate and things like that, and how to get around them by knowing what the genome, what the genetics are. Okay? And there's a lot more to methylation than just one step. There are many of them. All right? And we're also going to look at metabolic dysfunction as it's regulated by your genomics. So does everybody know what genomics means? Your genome. Does everybody know what genome means? Genome is the sum total of all your genes, right? That is your genome. Okay. So my why? Well, those are my 2 little guys.
Oh, the twins.
Reese and Oliver. Okay? That on that slide on the right, that's 4 generations. That's my mom, Lenine and I, who you would have met Lenine downstairs. My son and daughter-in-law and the twins, they live in the UK. They were just here 3 weeks ago. The twins are 16 months old. They have a sensitivity to dairy. They're nonverbal. Right? One is crawling, one is army crawling, was. 16 months. If you know about this stuff, you know the timeline, right? Lovely, happy kids. Because of the dairy sensitivity, my son and daughter-in-law were very good at taking the dairy out of the way, okay? But they never addressed the gluten. So when they got here, I said, okay, while you're here, no gluten, period. 0. The next day, the one that wasn't crawling was crawling. They are now both walking with a little help. 3 weeks. The next day after taking the gluten out, the one that wasn't crawling was crawling. The day after that, they both became verbal. 2 days. Right? When you get the right thing, if you're doing the right thing, you should notice a change quickly. This isn't something, let's try this for 6 months. You should be able to notice a change right away when you do the right thing. So who am I? I'm Dr. Glenn, obviously. I grew up here in Sarasota. I went to Baylor out in Texas. Initially I did physics. I taught electrical engineering for a couple of years. I decided I wanted to go back to school and become a doctor. And I had raced bicycles in Europe back in the 70s. And so I was very into the natural thing before there was a natural thing, so to speak. And I wanted to do something that didn't involve drugs because, well, racing bikes, you're not supposed to be taking them. Although they get very clever, don't they? Mm-hmm. Y'all all know who I'm talking about. We all said, the first time Lance won, it was like, way to go, Lance. Then he won again, and we go, Lance? Really? The third time, By the third time, those of us who know Lance knew. We just didn't know how. So I went to the National Health Sciences Institute in Chicago. I became a chiropractor initially. To me, chiropractic was like Newtonian physics for people. Something's out of alignment, you just put it back at the velocity, angle, and amplitude that it should be, and so forth. You just line it up like the front end of a car. I didn't know anything about medical politics, if you know what I'm referring to there. The opportunity came along in 1994 to move to Europe, and so we did, and while living in Holland, I did a neurology residency program at the Carrick Institute, and then I've just been doing brain stuff ever since the mid-90s. Those of you, anybody in here know Dr. Malello? Dr. Malello, the Brain Balance Centers?
Oh, yeah.
Yeah, I know Dr. Malello. I did his program, and I started treating kids, and I was very, very frustrated because some would get better and some wouldn't get better. All right, and then you can see the rest of that stuff if you want to later on. All right, so a few facts. This is why I said when we started, am I preaching to the choir? Because you guys know this stuff, right? You guys know this stuff. You know, now, what, 1 in 44 in the U.S.? I mean, this is, all right? But I want you to look at something. You see that? What happened? What happened right there in the mid to late 90s? Who knows? Anybody?
Our wheat glyphosate.
Yeah.
Bingo. What happened? That happened.
Agent Orange became
Roundup.
Roundup. Yeah.
Right? You can't take a perfectly good industry that developed out of Vietnam and not, what are you going to do? Tell all these people they're unemployed and send them home? No, let's make it and spray it on our food. That's a good idea. All right, we'll come back to that thought in a little bit. All right? So, there is a lot of evidence now that there is a big link between the immune system, autoimmune, and ASD. All right? So what causes autoimmunity? Well, we're going to hear from him in just a minute, but a fellow named Alessio Fasano. Anybody heard of Dr. Fasano? Good. Dr. Fasano, when he was at the University of Maryland in 2000, discovered something called zonulin. This is really important. When the intestinal lining becomes irritated, it makes this stuff called zonulin. He discovered it researching dysentery. If you get a bug and you try to get rid of the bug, and that's what your gut wants to do, diarrhea then becomes a good thing, right? Or think it's a natural response. You're trying to flush stuff out, right? So when you get irritated in the gut like that, you make this stuff called zonulin, and it breaks down the tight junctions between the cells in the intestinal lining. You with me? So that fluid from the blood can come into the intestine, so you get an increase in fluid and you end up with what? Diarrhea, right? Now hopefully it's temporary, you get rid of the bug and everything goes back to normal and off you go. Well, Fasano discovered this stuff back, and he first published it in 2000. What we now know is that anything that irritates the intestinal lining creates zonulin. We're going to come back to zonulin in a minute, all right? So what causes autoimmunity? Well, what we know first is that there has to be a gene to be turned on. You can't turn on a gene that isn't there. So if there are lights in this room, then there's going to be a switch somewhere to turn these lights on, right? Now they could be off, they could be on, they're still in the room. Okay. You have to have what we now call a leaky gut. When I first started reading about this stuff 10 years ago, it was called intestinal hyperpermeability in the literature because, well, doctors and researchers can't possibly use a word like leaky gut, right? That's not posh enough. And so it was called, now we just call it leaky gut. But the thing is when you make this zonulin and it breaks down the barrier between the intestine and the blood, the zonulin gets into the blood and it breaks down all of the tight junctions throughout the body. Relative to what we're talking about, what barrier would be very critical? The blood-brain barrier. Oh. Now when we get zonulin into the blood, it can break down the blood-brain barrier. All right, so you have to have a breakdown in that barrier, and then you have to have something called a trigger. And that trigger could be a lot of things. It could be food sensitivities, it could be toxins, it could be infections, it could be birth. It could be whatever mom got exposed to while the kid's in utero, right? You following me? So anything can be a trigger, well, or lots of things can be triggers. In my Alzheimer's patients, I see general anesthesia as a huge trigger. I see moving house as a big trigger for some people, especially if they didn't want to leave Ohio and come to Florida, which I can't possibly imagine, right? Okay, so when you put these three things together, you run the risk of developing an autoimmune disease. We're going to explain it a little bit more in a minute. This is a critical factor though. One autoimmune disease increases the risk of developing others by 300%. Why? Because you have a leaky gut, you have access to the genome. You with me? In other words, if you don't do something about one of those three things, Lenine, could you give me my pointer out of its, I believe it's in the desk drawer where you got my laptop. If you don't do something about one of those three legs, think about it as a three-legged stool. As long as the stool is standing, the opportunity to develop more problems is there. All right, so it becomes very important to address that. And I'm going to show you, we're going to look at a case of that in just a moment. So what we now know is, thank you, is that there's a large amount of evidence that supports widespread immune dysregulation in individuals with ASD. And when you get the slides, and those of you who came in after I said this, I will send you my slides as long as Lenine has your email address that you want to use. And you can check out these publications and stuff like that if you want to. You could just go to PubMed and type it in if you want. If you're inclined to read this kind of stuff. I find it really good to help me take my Sunday afternoon nap, to read research papers, all right? So, what we now know is that 46% of ASD families had 2 or more members with autoimmune disorders. Wow. So you know what, we look back at the increase in the incidence of autism? What else matches that same curve? Autoimmune disease. As a matter of fact, all chronic diseases are matching that same curve. That they all went hockey stick, if you know what I mean. You know what I mean? So it goes along like this and then it goes like that, right? That's the hockey stick, right? All of these chronic diseases match that profile with the upturn happening in the mid to late 90s or early 2000s. All of them. All right. A 2018 study at UC Davis at the Mind Institute, that Dr. Bredesen used to work at, found that children with autism had reduced immune system regulation as well as shifts in their what? What's the gut microbiota? Who knows? You know, because I heard you talking.
Well, it's the bacteria.
Bacteria that live in your gut, right? When I was in school in the early 80s, it was never mentioned. Nobody ever talked about the microbiome. But it's actually quite important. Also, it's not something I planned on mentioning today, but if you're taking probiotics, you need to be rotating the probiotics. Otherwise, you can get an overgrowth of good bacteria, or what should be good bacteria. But if you're taking the same thing over and over and over again for months and years, you can actually get too much of a good thing. It's kind of like if you live in Texas. We lived in a town in Texas, Tyler, Texas. If there were 100 restaurants in Tyler, Texas, 98 of them were Tex-Mex. Now, I like Tex-Mex, but that's too much of a good thing, right? Yeah?
I have a question. I read a study that most autistic kids have a deficiency in glutathione.
We're coming to that. All right?
Another nurse practitioner.
Okay.
Got it.
So what is a leaky gut? Or intestinal permeability is a condition in which the lining of the small intestine becomes damaged, causing undigested food particles, toxic waste, and so on and so forth, to leak through the intestines into the bloodstream. Okay, so I use this picture to understand what a leaky gut is like. So let's say what you want is coffee in the pot, right? Now, so that thing right there is your what?
Filter.
That's your coffee filter, and inside the area there are your coffee grounds, right? So what you want is the coffee. Same thing when you eat, right? You don't want broccoli in your blood. You want the nutrients from broccoli in your blood, right? Now, if somebody came along and poked holes in my filter, what would be in my coffee? Coffee grounds. Would that be good or bad? That would be bad. As a matter of fact, in my house, that would be very bad. But it would be my fault because I made the coffee. Now, think of it like this. If you went to get your cup of coffee in the morning and it was full of coffee grounds and you took a big swig of it, you would probably have a bad reaction, wouldn't you? You'd spit it out. Well, if you've got holes in the intestinal lining and you have stuff getting from the gut into the bloodstream that isn't supposed to be there, are you going to have a big reaction to that from the immune system? Absolutely. That's the way you're made. That is supposed to happen. You with me? Is it pleasant? No. Should it be happening very often? No. But if you have a big reaction to it, that's what is supposed to happen. That is your body functioning like it should. So, this is hard to see. Ooh, I wish that was brighter, but it's not. Lenny, can you turn off the lights for just a second? Let me see if I can show you this. That's a little better. Okay, I got this from a fellow I know at UVA, Zach Bush. And what he did in researching what glyphosate, we all know what glyphosate is, right? Glyphosate is the word for, that's what Roundup is made from, right? Okay, glyphosate is a pesticide. It's hard, you can't really see it. In this right here, can you see these little green lines?
Yep.
All right, see how they're close together? And there's little purple bits in the middle, right? Those are the nucleus of the cells. This is after 2 minutes exposure to glyphosate. Over here, I wish I could see this. You might be able to see it better when you get the slides. You'll see that these things are breaking down. When you get over here after 60 minutes, you see this area right there? That's a hole. That is a hole in intestinal epithelium for the nurse practitioners in the room. All right? That's a leaky gut. 16 minutes. 16 minutes after exposure to glyphosate, you have a leaky gut. So gluten damaging the intestinal lining is like pregnant. You either are or are not damaged. And once you damage the intestinal lining, it takes 5 to 7 days for it to heal, because you get a new intestinal lining regenerated every 5 to 7 days. So when I have a patient telling me, well, I only have pizza on Fridays, it's my treat. And I would say, well, you have a leaky gut then close to 100%, if not 100% of the time. All right? I'm bringing that up for a reason, because if you're going to try something, you have to, if you're going to implement, let's say, a gluten-free diet, you have to do it properly. So there is no such thing as gluten reduced. All right? You're either gluten-free or you are not gluten-free. Okay, I want to come back to that, to the whole gluten thing in just a minute. So let's see what happens here. Thank you, Lenny.
Can I ask a question? Is it really the gluten or the glyphosate? So if you...
It's actually both.
Because if you're doing organic wheat...
Hold on just a minute.
Okay.
So what you see here is this is a cell. These are the tight junctions, okay? The zonulin breaks down the tight junctions. It also destroys the cells. So now the things that are up in here can get through here and into the bloodstream. So that is what a leaky gut is, okay? So the question was glyphosate and gluten. Gluten irritates the intestinal lining, but you make an enzyme called DPP4, Roman numeral 4. DPP4 neutralizes zonulin. So, going all the way back to the Last Supper and before, people have been eating bread, right? Absolutely. Now, you make enough DPP4 in a healthy gut to offset a little bit of irritation. But when you go and spray wheat crops and other things like corn and so forth, when you spray them with glyphosate, and then nobody's out there washing the corn off before it's harvested, right? Besides it soaks in anyway. When you add glyphosate damage to the damage that gluten does to the gut, you end up with a situation which overwhelms the natural ability to deal with irritations in the gut. I developed a problem with it when I had to have a root canal 8 years ago, 9 years ago. I bit down on a nut on a Sunday evening. If you've ever bitten down on something and cracked a tooth, you get that like, oh dear. You know what you've just done, and you can't believe you just did it, and you hope you didn't do it, but you know you did. So you go to bed hoping that you'll wake up in the morning and it was a bad dream, but you don't. You wake up with your tooth hurting, right? So this was on a Monday morning. I called my buddy Radford, who's a dentist. He's my dentist. He's a great guy. I said, Radford, I think I cracked a tooth last night. He said, well, I can see you on Thursday afternoon. If it's cracked, we'll do a root canal. If it's not, we'll figure it out, but I can see you then. Fine, all right? In the meantime, I want you to take some, what, antibiotics, because if it's a crack, you don't want bacteria getting in there because the bacteria will expand it and make it hurt, right? So he sent me some antibiotics and he sent me some painkillers, which I took through the week like a good patient so that I could keep working until Thursday. I went to his office, it was cracked, had to have a root canal, and so on and so forth. And on Friday evening, her brother had built a wood-burning pizza oven in the backyard. So what did we do on Friday night?
Ate pizza.
Absolutely ate pizza. As a matter of fact, I think I probably ate 4 or 5 little individual servings. I mean, I was going after it, and some beer too. What's in beer?
Gluten.
Bingo. All right? All right. And I started to blow up like a blimp. And actually, I thought I was having a heart attack. I called my buddy Kenny, who's a cardiologist. I said, Kenny, I think I'm having a heart attack. Will you meet me at the ER? He talked to me a little bit. He said, Gary, it's not your heart. I don't know what it is, but it's not your heart. You know, all right? So what did I do? I do what everybody does. I Googled. Right? I Googled, and I started reading about gluten. Well, get out of here. I'm not celiac. I've been eating this stuff my whole life. Right? I had just taken a week's worth of what? Antibiotics. I had just destroyed my what? Microbiome. If I have a destroyed microbiome, how much DPP4 enzyme am I making? 0. So I just developed a gluten sensitivity. Well, I didn't believe that. I thought it had to be the tomato sauce. Somebody put MSG in the tomato sauce or some nasty thing like that, right? So the next week, all for science, of course, I got some clean, organic tomato sauce. And I ate a bunch of pizza again. Why? This is for science. This time I blew up so much, you don't have to visualize this, but I was actually pulling the buttons apart on my shirt. This was bad. I could not lie down. I had to sleep in a chair sitting up. And I said, then I Google some more. You notice how Google has become a verb, right? I Googled. So I was Googling, and I'm reading about this gluten stuff, and I said, this can't be, why? I should have learned about this in school if this was the situation. But I thought, well, I don't know what else could be. So we got some gluten-free pizza dough, and the third week, I ate some more pizza, and what didn't happen?
What?
Nothing happened. Okay. So, Dr. Fasano, here's the guy that discovered the zonulin.
The gene encoding zonulin was cloned in 2010. It turns to be located on chromosome 16, a very interesting chromosome, tiny chromosome. Only 3% of the human genome, 1,300 genes are sitting there, but it's packed with genes that are involved in many chronic inflammatory diseases, mainly autoimmune diseases, cancer, disease of the nervous system. So, for example, the genes for lupus, IBD, type 1 diabetes, RA is sitting there, like the breast cancer. Some of the lymphoma and the prostate cancer genes are sitting there. And finally, Lou Gehrig's disease, leukodystrophy, MS, and autism genes are sitting on chromosome 16.
That goes on for a little bit, but so what is sitting on chromosome 16? You with me? So if you have a leaky gut, and you have a trigger, and you have a genetic predisposition, you can turn on what? You can start to turn things on. Autoimmune stuff up here, like lupus, and type 1 diabetes, and rheumatoid, these are all nasty things. All right. Now, let's talk about something called molecular mimicry. Who's heard of molecular mimicry? Some of y'all have. No? Okay. Molecular mimicry is when the immune system mistakes one thing for something else. All right? And when that happens, we call them cross-reactive proteins. So antibodies bind to the specific protein sequences of antigens, while gluten, casein, and your own tissues may all be different. They share some of the same protein sequences. Now that can make one protein look like another, as far as the immune system is concerned, right? So, when you have something get into the bloodstream that isn't supposed to be there, the immune system attacks it, correct? Is that good or bad? That's good.
Oh,
No, that's good. It could be, if you ever saw anybody remember the show Hee Haw? And somebody be telling the story, go, that's bad. Goes, no, that's good. Then he fell out of the airplane. Oh, that's bad. No, that's good because he had a parachute. Oh, that's good. No, that's bad because it didn't work. Did you ever see that skit? If you did, just skip over this part. Okay. So what happens? So the immune system is supposed to attack any foreign things that get into the blood. That is normal. Now, when you start to break your food down, proteins are long chains of these things called amino acids. And what makes something a wheat versus dairy or broccoli or a tomato is the sequence of those amino acids. When you start to break proteins down though, if you have a hole in the intestinal lining that will allow a segment in, that segment could look just like something else. You follow me? Where it's supposed to only let individual amino acids through. But if the hole's big enough, and I just showed you how the holes get larger, now things can get through from the gut into the blood that aren't supposed to get in there. Like sequences of amino acids. All right. Now, so if this immune system antibody, if gliadin, which is one of the proteins in wheat, if it gets into the bloodstream, you develop a gliadin antibody. That's good, right? Because gliadin's supposed to be running around in your blood, right? You following me? Okay. Now, there's a sweet potato antigen. Can that fit in there? No, that won't fit right there, will it? All right? But this is casein. What is casein?
Milk protein.
That's one of the proteins in dairy, isn't it? All right? Now, can that antigen fit into that gliadin receptor site? Yeah, it's not a perfect fit, but it looks good enough. And if you're responsible for getting rid of bad stuff, and you want to do a good job, you're going to get rid of anything that even looks like what you've been told to get rid of. Now you develop cross-reactivity. It was gluten that created the problem, but anything that looks close enough to gluten, your immune system will begin to attack. What happens if that piece of protein that got into your blood looks like a piece of you? You just developed antibodies to yourself. That's called what?
Autoimmune.
That is an autoimmune disease. Absolutely. All right? So look at this. This is gliadin. Gliadin is a protein in what? Gluten. Wheat, right? What's that? That's your cerebellum. What's that? That's a part of your brain. That's a part of your brain that has to do with coordination, balance, stuff like that. Now check this out. Do you see how if this SNP got into the blood, the antibody could mistake that for it? It looks pretty similar, right? How different can people look from each other?
Very.
Very. But they're all people, right? So if you've been charged to go out and get rid of anything that looks like a person, you could be getting rid of a lot of things, right? Okay, so that's called cross-reactivity. Gluten cross-reactivity happens most commonly with dairy. Casein, the protein found in dairy, is similar to the gliadin protein found in gluten. All right? It's estimated at least half of those who are gluten intolerant are also sensitive to what? To dairy. All right. So, these findings suggest that neuroreactive antibodies may be causative rather than secondary to abnormal brain development in, because you could start attacking your own brain. That's not good. That's really not good, okay? These are two papers, you can look at it. This one right here is great. This is a fellow I know. This is Dr. Karasian's paper from Harvard. So, interestingly enough, a lot of this stuff is going on at Harvard or people from Harvard. Alessio Fasano found zonulin when he was at the University of Maryland, but now he teaches pediatrics at Harvard and runs pediatric gastroenterology at Mass General, which is top hospital. So, okay. So let's do a little case study so you can see how this works. Now this is not a child, but this will show you how this thing works. Now this is something called cerebellar ataxia. So David, a 42-year-old neuroradiologist, runs marathons and lives a very active life. He came into the office using a what? A cane, and said he'd been having difficulty walking for the last few months. He had seen several specialists. Well, of course he had. He's a neuroradiologist. All of his buddies in the hospital. He went and saw all of them. Nobody could figure out what was going on. He'd run MRI, CT scans, all this stuff. Unremarkable. It began about 6 months earlier with terrible what? Oh. How many kids with ASD have gut issues and food issues?
Oh, pretty much.
Pretty universal, right? Okay. He'd seen a gastroenterologist and had scopes and all of that. All right. As a desperate measure, he had eliminated gluten from his diet after reading Dr. Perlmutter's book, Grain Brain. That was one of the first ones that came out several years ago. Dr. Perlmutter, he practiced down in Naples. And he felt better, but the neurological symptoms continued. So his gut felt better, But the neurological thing continued. Because once you start an autoimmune disease, it doesn't like to stop, does it? Okay, so he called the office after having a chance meeting with my former partner in the hospital elevator. So what we did is we ran something called a Cyrex. Cyrex is a lab out in Phoenix. Who's heard of Cyrex? Anybody? Cyrex is a wonderful lab. Really good people out there. This is a blood-brain barrier panel, and look at this. He is out of range, and equivocal means that it's also going on. He has developed antibodies to what? Zonulin and lipopolysaccharides, which are in the brain. Well, we saw that, and we went over here, and we said, we need to run a more exhaustive panel and see what's going on. Now, these are all different types of tissues in you, all right? Like thyroid peroxidase. Well, that's a thyroid enzyme, but these are all things that you're supposed to have. Now, check this out. Whoop, I'm gonna go back. Okay, see that right there? He has developed antibodies to his what? Cerebellum. If your cerebellum is responsible for you being able to walk and you develop antibodies to it, what do you think you might have trouble doing? Cerebellar, it's called cerebellar ataxia, all right? So we thought, well, we've got to find out then what's going on. So we ran a very exhaustive food sensitivity panel. Everything showing up over here in red is an issue. But I'm going to get to a particular page. Right there. See that right there? Orange juice happens to be cross-reactive with gluten and cerebellum. All right? What do marathon runners drink large glasses of every morning? Orange juice, right? Well, because they're burning off so many calories, they can get away with drinking that much sugar. I can't get away with it. Sugar's got as much, orange juice has as much sugar as Coca-Cola, right? But if you're running like 10 Ks all the time, you can get away with it. So what was he drinking every day? Orange juice. So you know what we took out of his diet? Orange juice. Calmed his gut down. See this? How's that?
How long did it take?
About 3 months. Pretty cool. Bingo. Back to running. This is cool. This is what it's all about. It's fixing stuff like this. Now, all right? So when you get your slides, I want you to look. These things here contain gluten. These things here are often contaminated with gluten. Who's noticed when you buy oatmeal it will say gluten-free on it? Well, how can it say gluten-free when oats don't have gluten?
Because they grow next to wheat and the gluten.
That's right.
Genetically modified.
What it's telling you is that the oats have been processed in a clean facility where there's no cross-contamination. All right? So these things, and then these things are cross-reactive. Cow's milk, and it doesn't matter if it's which kind. I know people are running around trying to get the A2 or whatever, you know. But if you've got a child that has ASD, and you want to find out if the diet's going to work, don't do one thing at a time. Do all of it. Do all of it, give it long enough to find out if it works. All right? Taking somebody off of gluten for a day isn't going to tell you anything. All right. So these things can be cross-reactive. So if there's a gluten thing going on, you got to pull all of this stuff out. Now this isn't fun, because what do little kids like to eat?
All of that. Cereal.
Cheerios. Cheerios are made from what?
Oats.
Oats. See? All right. I'm not telling you this is easy. All right. Now I want to get into metabolic dysfunction and DNA. So we talked about autoimmune. Autoimmune plays a big part in this. But now we're going to get into talking about what genetics, what the role is. So, as I mentioned before, your whole collection of DNA is called your genome. All right? And it's your unique blueprint. You have amino acids, and they're joined together And this is what makes up your DNA code. And you have about 3 billion of these going on in your DNA. That's a lot. Now, a SNP. Who's heard of a SNP? Anybody? Some of you have heard of SNPs. A SNP is when you take one segment of DNA and you change just one thing. Just one thing changes. Right? So I use this analogy for SNPs, because I like cars. So if you wanted a 66 Mustang, you could get that as a coupe, a convertible, a fastback. You could get it with a straight 6 or V8. You could get it with an automatic or a manual transmission. You could get it with factory air. In other words, they're all Mustangs, aren't they? But they're all different. So those are different SNPs of the same gene. Now me, I want a 289 fastback with a manual transmission and factory air. So if you find one, let me know. Okay. Now, SNPs are what make you unique. We all have eye color, but the SNPs determine which color you have. SNPs are equivalent to one word change in a recipe. All you have to do is change the one amino acid and the whole thing can be completely different. Right? We all look a little different, but we all look very similar. And it's these SNPs that make the differences. Okay. So there are many root causes and contributing factors to ASD that have a genomic component. Genomic means your what?
Genes.
Your genome, your genes. All right. So all of these things have a genomic side to them. Inflammation, infections, nutrient deficiencies. Are nutrient deficiencies common in ASD? Absolutely. What are some of the most common nutrient deficiencies you see? Some of y'all know this stuff. B12, vitamin D, right? Zinc. These are common nutrient deficiencies. All right? Brain plastic. What is brain plasticity? It's the brain's ability to do what?
Fix itself.
Change.
As you get older, it supposedly goes down, but it doesn't have to.
Yeah, well, it turns into fiberglass, which is not plastic at all.
Okay.
No, I'm just kidding. So brain plasticity is your brain's ability to change and adapt and things like that. All right, that's important. Gut issues, mitochondria, glutathione. We had somebody ask about glutathione, right? Or did you ask about glutamate?
Glutathione.
Okay. All right, and oxidative stress. So I'm not going to read through this whole thing, but what Intellex DNA has done is they've developed something called the Neurodevelopmental and Mental Wellness Panel. And these are just some of the panels that are in it. There's about probably 800 to 900 genes that are looked at. When the report comes back, it's about 180 pages. So it's a lot. But these are some of the things: autism spectrum, inflammation, environmental toxins, heavy metals. In other words, we're going to look at your body's ability to do lots of things, right? So if you want to read all that stuff later, you can. But these are the different panels that we look at, all right? So in utilizing genomics, we want to look at things sequentially. So we're going to use this analogy. The first thing you have to do is put out the fire. What has to do with that? Inflammation. Any of you see the movie or read the book Brain on Fire? Yeah, that was a good book, actually. That was what her brain was. She was making cytokines like crazy. Once you put the fire out, then you got to get in there and do what? You got to rebuild stuff. You got to clean out the garbage, right? And then you can redecorate and all of that. So let's see how that works. Well, inflammation, putting out the fire. Now, inflammation, we tend to think of inflammation as a bad thing. But it's not, it's a neutral thing. Think of it neutrally. Inflammation is necessary for what? If you get bitten by a mosquito, That red thing that comes up is what? Inflammation. Is that good or bad? Well, it doesn't feel good, but it is good. As long as it doesn't get too big, right? As long as you don't scratch it. Because that's how your body comes in and gets rid of whatever the mosquito put into you, right? If you fall down the stairs and twist your ankle and it gets inflamed, swells up, that's inflammation, right? That's the body rushing in with stuff to clean up the debris and repair tissue and all of that. Is it nice? No. But is it necessary? Absolutely. Okay? So I want you to, don't think of inflammation as being bad unless it is unresolved and chronic and it's out of control. Then it is bad. All right. So manifestations of inflammation in ASD, you'll see brain inflammation. That's a difficult thing to describe unless you've seen it or experienced it. Anybody experienced brain fog? You know, you have days when your brain just doesn't want to work. Sometimes there are days after you've done something you shouldn't have. That's brain fog. That's inflammation going on in your brain. Loss of cells, that's neurodegeneration. That's the flip side of neurodevelopment. We don't like that. Disruptions of memory, motivation problems, depression and anxiety. If your brain is inflamed, how well are you going to make and or utilize neurotransmitters? Not very well. So you could be depressed, anxious, loss of motivation, things like that. Sleep difficulties, oh my. How many kids with ASD have sleep problems? It's a big deal. As a matter of fact, we kind of grow up thinking that being able to function without sleep is like an asset or a benefit. It is not. Sleep is really important, and the more we learn about it, the more important it becomes. Proper sleep. You should be able to fall asleep easily, without help, in a reasonable amount of time at a reasonable time. So for an adult, if you lie down at 10 o'clock every night to go to sleep, you should be able to fall asleep easily without help. If you need help or you lay there for an hour or two, something isn't right. Same thing about during the night. You should be able to sleep through the night without waking up unless you have to pee, in which case you go to the bathroom, you get back in bed, and you do what? You fall right back to sleep. But if you get up at 2 or 3 in the morning, you go to the bathroom, you get back in bed, you lay there for an hour or so, or longer, that's a hormonal problem. That's not a I had to go to the bathroom problem. All right? Disruption of hormones, gut inflammation, all of these things are telling you that you are making something called a cytokine. Think of cytokines like the byproducts of inflammation. It's like the smoke when you have a fire. Now, if you've got a fire in the fireplace, you've got to do something with the smoke, right? Hopefully you get rid of it out the chimney. What happens if your chimney's blocked up? The fire that we don't do that very often here, but if you had a fire in the fireplace, I think the only time we ever used our fireplace growing up was to burn the wrapping paper from Christmas. Otherwise, why would a house in Sarasota even have one, right? But if you went up to North Carolina or something, having a nice fire in the fireplace, that'd be great, wouldn't it? That'd be lovely on a winter evening and all of that stuff. But what happens if the chimney gets clogged up? Something that was beneficial just became
toxic.
a problem. Okay, so think of the smoke as cytokines. That's the byproduct of inflammation. As long as you're getting rid of them effectively and efficiently, fine. All right. This guy right here, Raj, 15-year-old, he had several different types of inflammation, and this is what his DNA report looked like. He's got a problem with something called IL-1A, and down here he's got a problem with something called IL-1B. IL stands for interleukin, so if you're a health person, you know what this stuff is. IL-6,
They use it to
IL-1,
treat cancer.
all of these things, right? These are byproducts of inflammation, right? Now, as long as the process for getting rid of that works fine, it's not a problem. But this fella here, little Raj, he has a SNP, he's actually got a couple of them, that keep him from being able to break that down and get rid of it. Now, the wonderful thing about the panel that we use is it will, this is hard for you to see, but it will actually tell us diet, supplements, and other interventions that we can use to address that genetic SNP. So now what we can do is we can take a look and we can see where the problem for this little fellow is, and exactly based on the literature, what the best way to treat his inflammation is. Because what's good for inflammation? Turmeric, right? Resveratrol, B12 and folate for methylation. In other words, lots of things are good for inflammation, but which one does he need? Because you don't want to try to take a kid and give them 20 different things to take, right? It's not going to go over very well. So you want to be very, very specific. So what knowing the DNA does is it helps you to know what's the best way to deal with the pathway for that person, which could be completely different than for someone else. All right. Some of the supplements that target inflammation based on his DNA are sulforaphane. Who knows what sulforaphane is? Well, it tells you right there what it is. Broccoli sprouts. That's good for inflammation. Fish oil, resolvins, curcumin, anti-inflammatory probiotics. So when we look at his panel, it tells us right here what is the best thing to use to address this SNP. How cool is that? Now we're getting very specific. We're doing exactly what he needs. All right. Nutrients supporting the framework. Well, vitamin D is a big thing. There are a number of SNPs for vitamin D. Now, we've all been told, how do you get vitamin D?
Sun.
Well, the sun. Well, that's supposed to work, right?
But you won't hold on to it if you don't have certain things.
Now, this is I find this interesting. Vitamin D is like the Rodney Dangerfield of nutrients. It gets no respect. If you remember Rodney Dangerfield, he'd do up his tie and say, I get no respect. Two men come to mind. One fellow in particular, mid-70s, plays like 2 to 3 hours of tennis every day. He's fit, toned, killer tan, everything. We run his labs and his vitamin D comes back at 8. Now, if any of you know about vitamin D, anything lower than 30 is bad. But when you get to single digits, that's real bad. Ran his DNA, he comes back with a SNP that prevents him from turning sunlight into vitamin D in the skin. He can stay outdoors in the sun the rest of his life, and he will not make enough vitamin D. Now, that is something you would have never picked up on if you hadn't ran his DNA. It's as simple as it sounds. Vitamin D in the brain is like a switch that turns things off. How many times would you take a kid with ASD and want to turn some things off? Like excessive mitochondria activity and stuff like that, right? Bouncing off the walls, jumping all over the place. Maybe we need some, you follow what I'm saying? We always think we want to turn things on. Sometimes you want to be able to turn things off, right? Okay. So it'll tell us what is good for that. B12 also, so there's a B12 panel. This particular person has a SNP, so they are prone to lower B12 and lower folic acid, all right, as well as elevated homocysteine. Homocysteine is a lab marker for inflammation. All right, so we would know then that this person needed to probably do B12 via injection. That's the best way for them, or sublingual B12, as opposed to, let's say, a capsule or a tablet. That's going to be what absorbs best for that person. All right? Then you got to remove the toxin and stuff. And this is where your glutathione comes in. And Problems with detoxifying make it hard to cope with the environment. Addressing this, it's beneficial for ASD and ADHD, allergies, irritability, and all of this stuff. I see, when it comes to toxins, now we're getting into liver function. That your liver is what helps you get rid of the toxins that you get exposed to. Glutathione is something that's very important in the process of detoxifying. And yet, I probably see more people in my Alzheimer's population that have glutathione problems than probably anything else. And if you have issues with being able to detoxify, then what happens to the toxins in your body? They build up. So is mercury a good thing in your body? Probably not. How about mold? Probably not. What do we get exposed to a lot here in Florida? Mold. Big. Huge. As a matter of fact, I went out to UCLA in March of 17, and I trained with a guy named Dale Bredesen for treating Alzheimer's and dementia. And one of the things that was in the curriculum was talking about mold. Now, Dr. Bredesen used to run the Buck Institute at UCLA, Southern California. Southern California is what? It is a desert. How much mold do you think they have in LA? Probably not a lot. So mold was talked about like sort of, you know, oh, you might see mold every now and then. I come back to the East Coast, I talk to my colleagues on this forum that we have, and I'm reading, and it's like, how much mold do you see? I see mold all the time. It's all the way from Maine to Florida. It's like just this corridor of mold. I read an article maybe 3 or 4 weeks ago where the estimation is that 50% of the houses in Florida have mold in them. I don't like that. That's a lot. When you have mold in the house, mold spores, you know what I'm talking about? That's how it reproduces. If mold spores are in the air and you breathe the air, where do the mold spores go? Into your nose, right? Into your lungs, and the olfactory nerve sits in the top of this cavity right back in there above your nose, right? So when you breathe something in, you have these little nerve endings that whatever you breathe in stimulates those endings, and if it's coffee or roses or something like that, you say, oh my, that smells good. Because that gets dissolved into the mucus and goes back into your brain. You go, man, the coffee smells good today. But what happens if you're breathing mold? And that dissolves into the nerve endings and goes back into the brain and sets up camp. That's not good, is it? So if we have a glutathione problem with detoxing, and we have a big mold exposure, it might be a good thing to know about. Now, if we can look at the DNA and see that this patient has a problem with their detoxing, and we can do a few things to mitigate that problem, how effective do you think that treatment then will become? It becomes a lot more effective, all right? Okay, so there are gene SNPs that reduce the available glutathione, which correlates with increased mercury retention, susceptibility to the detrimental cognitive effects of lead, and stuff like that. Okay. Then you have to, once you've got to go in, you've got to start rebuilding stuff. And this has to do with mitochondria, methylation, dealing with oxidative stress and things like that, neurotransmitters and so forth. Now, who knows what a mitochondria is? Mitochondria are like little powerhouses, little power factories inside of your cells. They're really pretty important. And you can have mitochondrial problems on both sides of the spectrum. If you don't have enough mitochondrial function, you end up with lethargy, right? You can have decreased cognitive function because you have decreased mitochondrial function in the brain. You with me? Now, what happens if you end up with the other side of it, and instead of having decreased mitochondrial function, you have excessive mitochondrial function?
Hyperactivity.
Hmm?
Hyperactivity.
Hyperactivity, absolutely. And you said, this kid, you know, when the child is awake, they can't sit still. That can be the flip side of it. Now here's something that happens quite often. People with autistic children, they'll say, but he's so smart. If your brain is running 90 miles an hour, it's going to appear to be smart. You follow me? The child will come across being intelligent because their brain is going so fast. It's running faster than a normal brain. So it can look like they're really, really sharp. And sometimes they are. All right. So we're going to do a last case study, and I'm using this one for a very particular reason. This is Dr. Wade. She practices in Queensland, Australia. And this paper was just published a couple of months ago. Dr. Wade has been on the team that has been developing the new neurocognition genomic panel that is just coming out of beta testing. We've just been able to start getting access to it. And so there's a couple of papers written about this. And if you want, you can look that up. And there are several other case studies that are reported in the paper. All right? So, Callum, the reason I'm using this one is this shows what treatment does over a long period of time. It also shows how the results changed at a particular point when we got access to the DNA testing that we now have. All right. So, Callum's 4 years old. In Australia, level 3, meaning he needs substantial support. Nonverbal, some babbling, not responding to his name, highly sensory, right? Issues with noises, you know, you've seen this before. Massive stimming, everybody knows what stimming is, right? Unable to sit still, big meltdowns, violent with others, hitting and biting, constipated with impacted bowel.
Unhappy child.
Hmm?
It's one unhappy child.
One unhappy child. Now, a little aside here, constipated. Constipated tells you your brain and your gut are not talking to each other like they're supposed to. Normal is 1 to 3 times a day. Anything less than 1 to 3 times a day is not normal. 2 or 3 times a week is not normal. It may be common. And I use this analogy, or this thought, in my Alzheimer's. When I talk to people about Alzheimer's, they say, well, memory loss as we age is normal. No, it's not. It's common. Right now, 40% of North Americans are type 2 diabetic or pre-diabetic. Would you say diabetes is fairly common in North America? I would. Who would say, therefore, diabetes is normal? Of course not. No one in their right mind would say diabetes is normal. So just because memory loss is common doesn't mean it's normal. Just because constipation is common does not mean it is normal. If you're constipated or the child is constipated, you have a problem with this guy and this guy talking to each other. As a matter of fact, the interesting thing is you have a whole nervous system around your gut called the enteric nervous system. You actually have more neurons in your gut than you do in your brain. How cool is that? All right. At 6 years old, he started a gluten-free, dairy-free diet. All right. Still nonverbal, occasional word, more interactive, responding to his name, not as many meltdowns, very unfocused, hyperactive. He's got a problem with what?
Mitochondria.
Mitochondria. okay? He stopped harming others, started self-harm. That's not good. Bedwetting, 3 diapers full each night. And extreme what? Constipation. Okay. At 12, he had an IQ of what? What's 54?
Severely low.
That's not good, right? And then there's his ATEC score of 117. Who's heard of the ATEC score? Neurotypical, or what we would want to see, is under what? Less than 10. You get 117 is really bad, okay? Intellectual impairment, still self-harm, hand biting almost daily, severe bedwetting, nonverbal, no desire to socialize, unfocused and mentally lethargic, stimming, still stimming, sensory issues, chronic constipation, permanently on laxatives. All right. Came back to Dr. Wade at 15. What she had been doing up to this point were the typical things. Running organic acid tests, making vitamin and mineral recommendations based on labs. All right? It wasn't working very well, right? Okay. But he came back at age 15 to be rescreened using a larger 700 plus, and it's now more than 700, neurodevelopmental gene panel, the Intellex gene panel that we now have, all right? Language can be understood, but there's room for improvement. Struggles with conversations, still low socialized, focus and concentration is still a problem. His ATEC score went to 71. That's a good move, right? All right. So when we look at his genome, he comes up with something called a SHANK3 gene. The SHANK3 gene just so happens to be involved with nerve connectivity. And so what was done here is he actually had 2 copies of this gene. You can see right there it says that he has 2 variants. And what the gene does, or having these SNPs, makes it difficult to form nerve connections, leading to a disorganized nerve cell that can't properly transmit signals. You follow me so far? Okay. The increased risk of autism is over 500% higher for people who have this SNP. Right? So and when you have this SNP, you're going to have difficulty with social interactions, speech problems, and decreased muscle tone. Because the nerves can't do what? Talk to each other like they're supposed to. All right? So we're getting very specific now. It just so happens that you can support that pathway with what? How cool is that? Now, here's a very interesting thing. Kids that live in Louisiana very rarely have what deficiencies? Because they eat oysters all the time. That's true. Okay. All right. So what they've seen is that zinc can help this pathway. All right. Other things that can help that SHANK3 pathway are what? Melatonin. That might have something to do with his what? Yep. Blue light protection. What do we get blue light from?
Computers, they're in front of computers all the time.
Sit at screens all day, right? Okay. As a matter of fact, I use an app on my computer at home, because I'm often working at night, that takes the blue light out of it. So get yourself an app that will take the blue light out of your screen. Okay? And of course, and physical activity during the daylight. Because when you get outside in the daylight, you get away from blue stuff. Also, with physical activity, you make something called brain-derived neurotrophic factor. Brain-derived neurotrophic factor helps you to grow new brain tissues, like fertilizer for your brain. All right? He also had a SNP that caused problems in making choline. And that's an important brain nutrient. Now, you can take choline as a supplement. Choline is important to help repair nerves in the brain, and you need to replace choline, and you can use a supplement called cytocholine. Now, if you didn't run the DNA, how would you know that you needed choline?
Yes.
You'd be guessing,
Shut it
all
down.
right? All right? It's another variant that also helps the nerves talk to each other, and you can, it has to do with GABA function and things like that, all right? 16 years old, now that he's been doing DNA stuff and things like that, his IQ has gone to what? Now from 54 to 70, may not be Ivy League, but how big a deal is it in that kid's life?
It's a 50%.
One standard deviation.
It's huge. That alone will change his life
Keep him off access
forever.
points.
Okay? Became eligible to attend a mainstream school. Managed homeschooling well because of COVID. Bedwetting did what? Mom's happy about that. Condition dramatically improved, fully conversational, he's got good muscle tone and everything, and his ATEC score went to 21. He started off at 117. 10 or less is ideal. He's at 21. His IQ has gone up from 54 to 70. That's cool.
Wow. That looks like a pretty normal kid.
Looks like a pretty normal kid. Got a job at a gluten-free cafe.
Oh, yeah. That's smart.
Good. That's good. All right, he's employed, travels independently to work. They have a lot more public transport in Queensland than we do here in the US. All right, he's very social. All right, independently invites his friends to lunch. That's huge. All right, joined a gym, plays tennis. 17-year-old, passed his driving test. Now, I will tell you, in the UK and in Commonwealth countries, getting a driver's license is a whole lot harder than it is here. All right? It is a very grueling task. All right? So he passed his driver's test. He was voted school captain, completed 4 technical college certificates, done a barista course, works in the garden. All right? Ended up helping run a family friend's business online due to COVID. When the DNA became available, he went from not making progress or making very little progress to making huge steps in progress. From a position where if nothing had happened to this young man, he would have been care dependent the rest of his life, living in a room in mom and dad's house, right? So when you know where things are broken, you can be surgically specific about exactly what you do. That's what doing the DNA will do. So Intellex DNA is the company that we use. Intellex DNA, the spearhead, the brains behind it is Dr. Sharon Hausman Cohen. They're headquartered in Austin, Texas. Sharon she did undergrad and grad school at Harvard. Harvard keeps on showing up in this. You know, so there's a lot of this stuff going on in their research up there. I was out in Austin early May. There was an invitation only. There were only 30 of us that were invited to an advanced workshop on using genomics. Now, I use genomics primarily for my Alzheimer's patients. When I came back, I was telling Jane that probably half the people there were treating kids. And
I begged you to do this. I was like, please.
And I'm talking to them, and they're amazed at what we're doing with Alzheimer's.
Just want my parents to know about this stuff.
84% of our Alzheimer's patients get better for something you've been told you can't fix. They're amazed at what we're doing with Alzheimer's, and I'm listening to them talk about autism, pandas, and these sorts of things. The things that I had looked into a while ago, and the results were so uninspiring that I just decided to focus on cognitive decline. Talking to them has made me revisit what I'm doing. And that's why we're doing this today. Because I have a tool now. A tool that can make a difference. That's the cool thing about this. These are all the different panels that we look at. And in each one of these panels, there's probably going to be anywhere from 5 to 15 genes in each panel. So we're looking at about 800 genes, okay? Or maybe 20 genes, whatever that comes out to be. And you can look at all the things that are in there. And you'll know people that maybe they don't have ASD, maybe they got ADHD, maybe they have a problem with OCD. So it's not just ASD, but all of these different things. Even the pandas and the pans. You can now look at those, and you can look at the genetic side of it, and you can make a real big difference. Okay. Has this been helpful?
Yeah.
All right. Now, if there's anybody here that would like to come, if you have a child, I don't know, that's why I said in the beginning, I didn't know if I was pretty much talking to the choir or not. But if you have someone that you would like to talk about, what I'm doing is, normally I charge $2.99 for an initial consultation. But if you'd like to come in, sit down, go over the situation, decide whether or not this is something that should be pursued, that it matches what you need, then we're offering the opportunity to come in for $149. All right? Lenine has a sign-up sheet, right? No, you have, yeah, she's going to pass it around. And if you would like to take advantage of this, you can fill this out and hand it to Lenine. Also, if you'd like to take advantage of this, there, Nina, who's over there reading right now. Nina will give you a packet. The intake form for this is about 15 pages. I'm going to ask you a lot of questions, an awful lot of questions. And what we'll do is we'll sit down, we'll go through the situation. If there's certain testing that should be run that has not been run, such like an organic acids test maybe or something like that, we can talk about that. A lot of parents have already done that test, right? But if it looks like running the DNA is appropriate, then we can do that. So if you'd like to just come in and have a chat, then that's what this is for, okay? So here's what I ask you to do. Lenine will hand the sign-up sheet to everybody. Fill it out. Nina will give you an intake form. She'll schedule you if you know what your agenda is. If you don't, you can just go ahead and get the form, and then you can do that through email or over the phone. And it's really important that I have a chance to go through the paperwork thoroughly before you come in. You don't want me reading 15 pages of stuff while you sit there using up your time. So I ask that you have your intake form back to me 48 hours before your visit. Please don't send it over on Friday afternoon for Monday morning. That is 48 hours, but do like to have a weekend. All right. Now, I'm going to go get a bottle of water. Well, I should have started my bottle of water. Okay. And if there's something you want to talk about, I'm going to stand right out here as soon as I go have some water, because I'm getting kind of horsey.
Thank you very
You're
much.
welcome.